morning, Varanda. Good morning, Varanda. Myself, K.B.N Devi, Department of Mathematics. Today we can discuss about the topic numerical differentiation. Okay, first we can define, first we know what is meant by numerical differentiation. Okay, and then in the previous classes you are already learned what normal differentiation in intermediate level and degree first year also. You can write different numerical differentiation. But in this semester we can learn numerical differentiation. First we can define what is meant by numerical differentiation. Let y is equal to f of x be a function. The process of evaluating the derivatives of the function of f of x with the help of the given set of values of that function is known as numerical differentiation. If any problem we can done the differentiation in normal way, but in this model we can done it is by using numerical differentiation. That means we can give the set of values given function y is equal to f of x. He is given x values, then we can evaluate y values. By using x and y values, we can find the derivative of the given function by using numerical method. The differentiation is known as numerical differentiation. Let y is equal to f of x be the given function. The process of evaluating the derivatives of the function of f of x with the help of given set of values. Given set of values means suppose he is given the data, given the values, x values. Now we can substitute, we can make the table. After we can find the derivative of given function by using the numerical data. The differentiation is known as numerical differentiation. In this numerical differentiation, we can apply so many methods. And we can use in the previous units we are already discussed about Newton forward, interpolation formula, backward, Stirling's, Newton's divided difference formula, and so on methods. But in this session we can discuss about Newton forward interpolation formula. By using Newton forward interpolation we can find the first derivative and second derivative. Okay, right. Next we can find derivative by using Newton forward interpolation formula. In the previous sessions we are already learned the formula Newton forward interpolation formula. We know that the Newton forward interpolation formula is, right, y is equal to y naught plus u into delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus u minus 1 u minus 2 by 3 factorial delta cube y naught and so on, where u is equal to x minus x naught by h. This formula goes to Newton forward interpolation formula. Once I repeat the formula, y is equal to y naught plus u into delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus u minus 1 u minus 2 by 3 factorial delta cube y naught and so on, where u form goes to x minus x naught by h. In this formula we can use the previous units, but in this numerical differentiation we can use this formula. We can write first derivative and second derivative forms. We can write first derivative form goes to dy by dx at x is equal to x naught. Formula goes to 1 by h into delta y naught plus delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta power 4 y naught plus and so on. That means 1 by h delta y naught 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. Shortly you can remember that formula, plus minus plus minus plus and so on. That means first derivative delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta power 4 y naught plus and so on. Plus or minus alternative goes and we remember 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. Next you can find second derivative delta square y by dx square, d square y by dx square at x is equal to x naught. Formula goes to 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta power 4 y naught minus 5 by 6 delta power 4 5 y naught and so on. Okay, second derivative start with delta square to start avudandi. Here is also plus minus alternatively plus or minus k. So this one is starting with delta square, second derivative starting with delta square. First derivative starting with delta y naught. So delta square y naught minus delta cube y naught plus 11 by 12 delta power 4 y naught minus 5 by 6 delta power 5 y naught plus and so on. So in this model we can find the numerical differentiation. We can use first derivative form, second derivative form. First derivative form is goes to shortly you can remember it as 1 by h into delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta power 4 y naught plus and so on. Is it clear? Second derivative d square y by dx square at x is equal to x naught. Form goes to 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta power 4 y naught minus 5 by 6 delta power 5 y naught plus and so on. Now we can done some problems in this model. Right. Now he is asking find dy by dx and d square y by dx square at x is equal to 1 from the following data. But he is not mentioned by using Newton forward or backward. Then how we can find the means? That means he is asking at x is equal to 1. And he is asking the value, that value is near to starting values, then you can apply Newton forward interpolation formula. Suppose if he is asking the x value in the last values, then apply Newton backward interpolation formula. Is it clear? He did not mention the method. So at x is equal to 1, that means starting value is near. So he is asking dy by dx and d square y by dx square. So given data goes to x values goes to 1, 2, 3, 4, 5, 6. Corresponding y values goes to 1, 8, 27, 64, 125, 216. Okay. First we can make the table. The forward difference table is, first we can write x values. X values goes to 1, 2, 3, 4, 5, 6. Corresponding y values 1, 8, 27, 64, 125, 216. Okay, x values, y value. Now we can calculate. Here x values are 1, 2, 3, 4, 5, 6. So here is x value 6. We are getting 5 differences. Up to 5 differences. First difference, second, third, 4, 5. First we can calculate first difference. That is y1 minus y0. 8 minus 1, 7. 27 minus 8, 19. 64 minus 27, 37. 125 minus 64, that is 61. 216 minus 125, that is 91. So we are getting first difference. Okay, next you can go by second difference. Second difference means down. 19 minus 7, that is 12. 37 minus 19, that is 18. 61 minus 37, that is 24. 91 minus 61, that is 30. So we are getting second difference. Now we can go for third difference. 18 minus 12, 6. 24 minus 18, 6. 30 minus 24, 6. Okay. So we are completed third difference. Now we can go by fourth difference. Here is all values are the same, 6, 6, 6. So 6 minus 6, 0. 6 minus 6, 0. Obviously you are getting fourth difference is 0, 0. And finally fifth difference is 0 minus 0, 0. So now you can make forward difference table. In the forward difference table, always we are considered as upward values. Okay. That is starting value 1, 7, 12, 6. So why not y values 1, first difference 7, second difference 12, third difference 6. Obviously fourth and fifth are becomes to zeros. Okay. So now we can apply the forms. He is asking dy by dx and d square y by dx square. Already we have learned the form. Dy by dx form is goes to dy by dx at x is equal to x naught. X naught means he is asking x value. X is equal to what? That is x is equal to x naught. That is x is equal to 1. So given x is equal to 1, x naught is equal to 1. You form in cheppamandi x minus x naught by h. that is 1 minus 1 by 1, that is 0. So u value becomes to 0 and dy by dx formula ఏంటంటే మనకి 1 by h is equal to delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta power 4 y naught plus and so on. This is now he is asking at x is equal to 1. H value is goes to 1 because internal difference is 1, 2, 3, 4, 5, 6. So x values all are common difference, that is h is equal to 1 because we can say that x is equal to x naught plus ah, x naught plus a plus x naught plus a to h and so on. So h value goes to 1. Now we can substitute all values. Delta y naught is 7, delta square 12, delta cube 0. Okay, now we can substitute all values. 1 minus 1 by 2, 12 plus 1 by 3 into 6 and so on. Now you are getting 7 minus 6 plus 2, 7 plus 2 9, 9 minus 6 3. Okay, second derivative d square y by dx square formula goes to 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta power 4 y naught minus 5 by 6 delta power 5 y naught plus and so on. So you are getting, after we can substitute all values, you are getting the values delta square delta cube, that is 12 minus 6, that is 6. So we can evaluate dy by dx at x is equal to 1 is 3 and d square y by dx square at x is equal to 1 is 6. First derivative is 3 and second derivative is 6 by using in which method? Newton forward interpolation formula. We can evaluate first derivative and second derivative. Okay, next derivations by using Stirling's formula. Already in the previous chapters we are already learned what is meant by Stirling's formula. Okay, in the Stirling's formula we can write first derivative, second derivative forms. dy by dx at x is equal to x naught formula goes to 1 by h into delta y naught plus delta y1 by 2 minus 1 by 6 delta cube y minus 1 plus delta cube y minus 2 by 2 plus 1 by 30 delta power 5 y minus 2 plus delta power 5 y minus 3 and so on. Here we are getting plus or minus alternatively, plus minus plus minus. This is the first derivative of Stirling's. We can use Stirling's formula, we can evaluate first derivative. Now you can write second derivative d square y by dx square at x is equal to x naught 1 by h square delta square y minus 1 minus 1 by 12 delta power 4 y minus 2 plus 1 by 90 delta power 6 y minus 3 minus and so on. Here is also we are getting plus minus alternatively. Again we can repeat. First derivative form goes to dy by dx at x is equal to x naught is 1 by h into delta y naught plus delta y1 by 2 minus 1 by 6 delta cube y minus 1 plus delta cube y minus 2 by 2 plus 1 by 30 delta power 5 y minus 2 plus delta power 5 y minus 3 by 2 and so on. Here is you can remember all are odd terms, delta power 1, delta cube, delta power 5. You can shortly remember it is these all are in odd terms. Second derivative d square y by dx square at x is equal to x naught formula goes to 1 by h square delta square y minus 1 minus 1 by 12 delta power 4 y minus 2 plus 1 by 90 delta power 6 y minus 3 minus and so on. Here is all are in even powers 2, 4, 6. First derivative odd powers 1, 3, 5. Okay, right. Now we can done a small problem in this model. Find dy by dx and d square y by dx square at x is equal to 6 by using Stirling's formula from the following data. So x values he is given 4.5, 5, 5.5, 6, 6.5, 7, 7.5. So all our x values common difference entundandi. What is the common difference of x values? 4.5, 5 that is 0.5. you can add 5 plus 0.5, 5.5. 5.5 plus 0.5, 6. That means common h value is goes to 0.5. And he is also given corresponding y values 9.69, 12.90, 16.71, 21.18, 26.37, 32.34, 39.34. Okay. Again we can frame the forward difference table. Firstly we can calculate, we can write, firstly we can write x values 4.5, 5, 5.5, 6, 6.5, 7, 7.5. Corresponding values he is given. First we can calculate delta y. That means first difference y1 minus y0. 12.90 minus 9.69. Then you are getting 3.21. 16.71 minus 12.90. 3.81. 21.18 minus 16.71. That is 4.47. 26.37 minus 21.18. That is 5.19. 32.34 minus 26.37. That is 5.97. 39.15 minus 32.34. That is 6.81. We are calculating first difference delta y. Now you can calculate delta square. So 3.81 minus 3.21, 0.6. 4.47 minus 3.81, 0.66. 5.19 minus 4.47, 0.72. 5.97 minus 5.19, 0.78. 6.81 minus 5.97, 0.84. So we are calculating delta square. After we can calculate third difference, 0.66 minus 0.6. Then you are getting 0.06. 0.72 minus 0.66. That is 0.06. 0.78 minus 0.72. 0.06. 0.84 minus 0.78. That is 0.06. Okay. Right. Here is we are getting third difference. Now we are making fourth difference. Here is x. Here differences are all are same. 0.06, 0.06, and then obviously you are getting fourth difference is zeros and fifth difference is zeros, and also sixth difference is zeros, because x values are 1, 2, 3, 4, 5, 6, 7. Here x values are 7. Then you are getting obviously 6 differences. Okay. Next we can evaluate first derivative. He is asking first derivative and second derivative. At x is equal to 6. X is equal to 6 means that is we are consider it as x naught. Okay. Next we can write the forms. dy by dx at x is equal to x naught. That means x is equal to 6. 1 by h. Formula is delta y naught plus delta y1 by 2 minus 1 by 6 delta cube y minus 1 plus delta cube y minus 2 by 2 plus 1 by 30 delta power 5 y minus 2 plus delta power 5 y minus 3 by 2 minus and so on. Okay, all are in odd terms 1, 3, 5 plus minus plus and so on, plus minus and so on. Now we can substitute delta y naught plus delta y1. Here is values 6. We can start with 6. This is corresponding with y naught delta y naught plus delta y1. That is 4.47, 5.19. This is x naught. This is y naught delta y naught delta y1. Once I repeat, this is he is asking at x is equal to 6. This is x naught. This is y naught. That is delta y naught delta y1. Okay. Now you can substitute 4.47 plus 5.19 by 2 minus 1 by 6 into third difference. That is, this is x naught, x1. Third difference is goes to values. Delta cube y minus 1, delta square. Now you can substitute all values. Minus 1 by 6 into third difference is values 0.06 plus 0.06 by 2. After we can simplifying, first of all we can add these two numbers dividing with 2. Then you are getting the answer 4.83. minus, again you can add these two terms, 0.06 plus 0.06 by 2, 0.06 in by divided by 6, then you are getting the value 0.01. So finally 4.83 minus 0.01 and multiplying with 2, then you are getting the answer 9.64. Okay, this is the first difference, first derivative. Now you can write second derivative, d square y by dx square at x is equal to x naught. Formula goes to 1 by h square delta square y minus 1 minus 1 by 12 delta power 4 y minus 2 plus 1 by 90 delta power 6 y minus 3 and so on. Here is delta square, delta power 4, delta power 6. Okay, but in the given problem we are getting the table delta power 6 is 0. Okay, delta power 4 it is also 0. We are getting delta square only. This is delta y naught, delta y1 corresponding value 0.72 because up down. So value second difference value is 0.72. Obviously fourth difference is 0, sixth difference is 0. So you can substitute these values. Delta square, delta power 4, delta square is 0.72 and delta power 4 0. This is also 0. 0.72 minus 0 divided by 0.5 whole square because h common difference is 0.5. So 1 by 0.5 whole square into 0.7. So after simplifying you are getting the answer 2.88. By using Stirling's formula in the numerical differentiation we can find first derivative 9.64, second derivative 2.88. So in this session we are learning two methods. By using derivatives, by using Newton forward interpolation formula we can evaluate first derivative, second derivative. And the second model is goes to derivative by using Stirling's formula. In this formula we can evaluate first derivative, second derivative. In a similar manner we can done Newton backward interpolation formula. Okay, thank you.